This meeting is being recorded.
For problem 19 from chapter 20, we're asked to predict the major organic products for each of these following reactions. So in part A here, we see that we have this acid anhydride, and it's going to be reacting with phenol. So this will result in the replacement of the carboxylate leaving group with the phenol oxygen atom. So if we were to draw our predicted product, it would look something like this. We would have our phenol on this side of our anhydride, and then the oxygen atom from the phenol would be replaced here. So we've seen similar products in previous example problems when phenol reacts with an anhydride. So this would be our first product, and we would also produce a carboxylic acid from this half here as well. So we would see also with our products this carboxylic acid as well. All right, so that's part A, when we react to that anhydride with phenol. Let's see what happens in part B here. So now we have this acid anhydride here reacting with excess of this diethylamine. So what we're going to see is if we orient our carbonyl in the same fashion, we're going to see that we create this amide here, right? And we'll have those two ethyl substituents still attached. So we have this amide, and then we're also going to generate this carboxylate ion as well in chapter 23, which we won't discuss in this course. Due to pKa values, we would see that in excess amine here, we would have a shift to just generate this carboxylate ion and not the full carboxylic acid. But since we won't get to that chapter, you can expect these two products. So part C here, this is similar to what we would see in part A, but now our acid anhydride is listed over the arrow, and then we have our phenol parent over here. So what we would expect is that the acid anhydride would be connected kind of here. So let's see if we can draw this product in the same orientation here. So we'll have our tert butyl group over here. We'll have our benzene ring, and then we also have this substituent here. That methyl substituent didn't go anywhere. And then up top here, we would have the rest of our anhydride kind of looking like this. So this portion here is now where that phenolic oxygen was. So that's where the attachment is there. And then we would also generate carboxylic acid from this portion here. So these would be our two products. And then in part D, we would see a similar reaction to what we saw in part B when we have that excess amine present. We can see that over here we have excess of this secondary cyclic amine. So what would happen is it becomes deprotonated. We insert this portion here of our acid anhydride, and then we would result with the carboxylate ion as well here. So let's draw that, since we know that this would remain. Again, this is a reference to different in pKa values, why this would not form the carboxylic acid. And then our other product would look like this. So let's draw that ring with the nitrogen atom involved. And then coming out of the top, we would see our carbonyl from this portion here. So these would be our two products for the last example for part D. Again, parts B and D remain with that carboxylate ion instead of the carboxylic acid due to differences in pK values.